All right, so is this sound good? The visual is good? All right. So good morning, everyone. I hope you had a good night's sleep, or well, if you didn't, I hope you had a great cup of coffee. Um, Let me introduce myself first. My name is Stefan Tran. I'm a software developer at Matrox Video, and I'm mostly working on AI projects here. And today, I'd like to talk to you about using AI as a vehicle for innovation at Matrox. So before we start officially, um, you may have heard lots of word about AI and deep learning, artificial network, neural network. So you may ask yourself, is it the hype, a temporary thing, a phase, or is it not? So let me show you some quotes from different organizations uh, all around the globe. So Forbes, a business magazine, they pretend that spending on AI software will top 800, 125 billion by 2025. As for the government of Canada, just only for the Montreal AI ecosystem, it has benefited from nearly $1 billion in public funds, which is a lot just for Montreal. Um, Also, we have Accenture, a global Fortune 500 company, and they pretend that 84% of business execs believe that they need to use AI to achieve their growth objectives. So it's not it's big names here that think that AI is something that should stay and well worth investing. So personally, I think that AI is here to stay and for good. We're gonna see later why also. So let's start. Today, we'll go over quickly about who are the people at Matrox Video, what kind of products we're developing here, and then we'll jump right into a quick introduction about what is artificial intelligence and its context, what kind of tasks it can accomplish, examples of applications. Right after that, I'm going to show you two examples of current Matrox Video AI projects, just to give you an example of how we can use AI to add a plus value to existing Matrox VDI products. And at the end, I'll do a quick summary of what we've just talked about, and finish with some tips and like resources for your first AI projects, and hopefully you can use them here at CodeJam. I'm keeping it at the end because I have to find a way to keep you until the end, right? So Matrox, in a few words, Matrox was founded in 1976. You may have heard it was founded by one of the co-founders that you may have heard yesterday, Lauren Trotti. In the early days, we were a major player in the graphic cards market. Some of you might even have played old PC games with Matrox video card. But now we're more focused on business related professional solutions for pro audio visuals, video and imaging applications. And we target a wide range of applications and market. So we're targeting broadcasting and media market, educational institution, government institutions, medical, manufacturing, etc. And there's two divisions here at Matrox. There's Matrox Video, in which I'm gonna focus my presentation on, and there's also Matrox Imaging. You may have heard about them with the workshops that were presented this morning and yesterday. So here are a few examples of Matrox video products. They're quite interesting. So the first one I want to present to you is the Matrox M264. So it's basically a PCI board where you can encode and decode H.264 streams. So you can process several video streams in parallel. And the goal here is to accelerate this the encoding and decoding. And the goal is also to offload the task out of the CPU, so you can do other tasks with your CPU. Another card we have is the Matrox ST2010. So this is another PCI Express card where you can capture, process the incoming stream, and then you can either send it to your computer, record it, do some additional processing, and you also have output ports where you can send out the video. And what is interesting with this product is it's all over IP video interface. A nice product here that I like a lot is the Mavix encoder box and the Mavix decoder box. The goal here is you have the encoder box, which has multiple inputs, so you can capture multiple inputs at the same time, record it on a USB key, external disk, or you can send it over IP, so someone else on the network or anywhere in the world, they can view your the input of the Mavix encoder. So an example of applications here would be in universities, where you would have a camera that's filming the teacher with the whiteboard on one input, and on the other input you would have let's say a computer with the PowerPoint slides. So the Mavix encoder would encode it, record it on a external drive, and also send the stream remotely over IP, so students all over the world can access that class. So that's a nice application for universities. Another product we have is the XIO. The purpose here is to be able to control simultaneously multiple systems remotely with your XIO. Another one here is the Mira IPX. It allows you to create very nice and large video walls. You can manage up to 16 HD streams in parallel. So it's the kind of stuff you can find in airports, restaurants, command centers, surveillance centers. So that's a couple of Matrox products. We have obviously a lot more. So I just wanted to show you the most interesting one, in my opinion. But they're all interesting, of course. So as you can see, there's lots of technologies that are involved in the Matrox video products. For instance, we have the chance to play with multiple video interfaces, HDMI, SDI, DisplayPort, video over IP. We also have the chance to play with different communication protocols, Ethernet, USB, PCI Express. Also, here we also design lots of video processing algorithms. So a scaling engine, composition, video codecs. That's the kind of stuff we are developing here in Matrox Video. And also we are developing on multiple platforms. So it's not only software, we also develop on FPGAs. We have ASICs, we are developing embedded systems. And now the next technology that we are very interested in, and that is currently in work here at Matrox Video, is artificial intelligence. So who are the people, wonderful people who are working on these wonderful projects? So we're approximately 300 employees in Matrox Video. They are software developers who are working on low-level stuff, core technologies, high-level applications. We also have a hardware department where we have hardware engineers and hardware technicians designing boards, boxes, enclosed boxes. We have FPGA designers, quality assurance people, tech supports, and many, many more. I just don't have enough place to put them all in the slide, but we're a big family here. Okay, now let's jump into AI. So grab your notebooks and start taking notes. I'm just kidding. We're gonna start with a little AI history course. So most of today's algorithm they existed a long time ago. For instance, the first artificial neuron was developed by McCulloch and Pitts in 1943. So it's relatively old. Other examples of early applications in 1965, the first multi-layer neural networks were developed, and it's the deep neural network as we know today. Another interesting applications is the LeNet-5, introduced in 1998 by Jan LeCun. Its task is to basically recognize handwritten digits, and I think it was for to recognize zip codes for the post office. And it's based on the convolutional neural network, the CNN, which was introduced in 1989. And this techniques here would lay the foundations of what would be the modern computer vision approach today, the deep learning approach. So as you can see, it's AI as we know it today. It's relatively old, but what explain why we didn't hear about it as much as today 10 years ago? Why is it a hype right now? Why are we talking so much about AI right now? It's because of three key elements. The first one being data, the second one being computational resources, and the third one, AI expertise. So let's talk about the first one, data. You may know that machine learning requires a lot of training samples. Usually, the more data you have, the better your model will be at predicting stuff. So now we have lots of data available because of social networks. Everything is connected right now with the internet. So lots of data are now available. So we're now more. It is now easier to make better AI models. Secondly, GPUs, specifically GPUs, they are getting cheaper and cheaper and better. They're getting stronger and better at computing complicated operations. So training large networks with large data set, usually it's very computationally expensive. So with the help of cheaper and stronger GPU, it is faster to train your model. And lastly, but not the least, there are more people that are interested in AI and doing research in AI, and that helps improving, optimizing, and better understand machine learning algorithms. So you may have heard that big tech companies such as Google, Amazon, Microsoft, Facebook, they are investing massively in AI research. So it's something that helps a lot the AI field. Interestingly, in 2012, There's a model called there's a model called AlexNet. It's a object recognition model, and it was the first time that a deep learning approach won the image recognition competition called ImageNet. So prior to that, it was more of a handcrafted object recognition algorithm. So from 2012, there's lots of interest that lots of interest for computer vision with deep learning with a deep learning approach. So that's three key elements that help the AI growth. So let's compare yesterday's model and today's model. The LeNet 5 model in 1998 was 60,000 parameters strong, and its purpose was to recognize handwritten digits, right? So at the time it was a huge model, and I think it took quite a long time to train, because computational resource at that time was not as strong as today, right? But now in June 2020, there's a new model called the Generative Pre-trained Transformer 3. It's a big, ferocious model with 175 billion parameters. So if you would try to locate the model on the graph on the right, it would be somewhere not on my screen. You wouldn't be able to even see it. So the GPT-3 purpose is to well, there's actually a lot of tasks that GPT-3 can tackle. You can do question and answering, text synthesis, text summary, arithmetics, code synthesis. There's actually a very nice applications where you would have a text box. You would you would describe what kind of UI you would like. Let's say I want a window with a big red button with stop written on the button. GPT-3 would be able to generate the code to generate what you just described in the text box. So it's getting, applications are getting crazier and crazier. All right, so there's a lot of words related to artificial intelligence, right? It's very easy to get mixed up with all these words, concepts. So let's start with what is the difference between AI and machine learning. So first, artificial intelligence is simply the global concept of machine intelligence. In other words, it's a system with cognitive abilities. So you can, as you can see, it's a very large definition that can include lots of concepts. So you would talk about AI as more of a global concept of machine intelligence, while as machine learning actually is a part of the AI family. And machine learning is a self-learning algorithm which requires training data to improve itself. So it's a subgroup of AI. And in the machine learning family, you would find the artificial neural network and deep learning. So artificial neural network is simply a way to do machine learning. All right, so there's a lot of tasks that you can accomplish with artificial intelligence, and also lots of applications. So we'll go over some of them. I'll explain what's the difference between these type of tasks. The first one, and I think the most popular, the most common, is a classification, the classification task, where the model, the AI model, is trying to output the class in which the input belongs to. So for example, you would have at your model input an image of a cat, dog, rabbit, etc. So the model would try to categorize what type of animal, what animal is it that I'm seeing at my input. So this is basically classifications. You would have binary classification, which is a two-class problem, and you would have multi-class classifications. An example of multi-class classifications would be the handwritten digits recognition, where you have 10 class, so 0, 1, 2, up until 9. So example of inputs you can process with these kind of tasks is there's almost infinite possibilities. You can process images, set of features like statistical informations about something. As long as you can quantize something, it's processable by the AI model. You can process text, audio samples, and so on. Examples of applications, we would have object recognitions, as you can see on the top right here. You would also have object detection, system control, and so on. On the other hand, you have a regression task where the model is trying to output a continuous numerical value based on what he's seeing at the input. So here we're trying to predict a value based on a set of input or features. So for the regression model, it's trying to modelize the relationship between the input and the output here. And examples of applications, you would have electrical load prediction on for the electrical grid, traffic prediction, insurance fee based on a person characteristics. Very popular regression task and nice first AI projects too is a house price prediction task application, where you would have a set of house characteristics such as the number of bedrooms, square feet, number of garage, and your AI model would try to predict the price at which you can sell your house. Well, so some other tasks here, you would have segmentation, where you would try to categorize each pixels in an image. Here, the goal is to distinguish different objects in a frame or a video sequence. So it's very popular, especially in the autonomous vehicle application. On the right hand, you also have the clustering task, where you would here the goal is to regroup similar data together, and it's useful for when you have a database with a very large database with unknown database, or you don't really know what to expect from the database, what you can find. So you can use clustering algorithms to help you find hidden patterns in a very large database. Here are some examples of applications. You can use AI to denoise images or video. So let's say you're having artifacts with your JPEG compression. You can remove some corruptions here. You can remove text out of an image. Let's say you have a watermark image, you can remove the watermark out of the image. You can do denoising. So it's quite interesting what some AI model can do. On the right side, you have synthesis and deepfakes. So the first one being creating artificial data out of what the AI model has learned. So you can create synthetic text, synthetic faces, musics, and so on. And the second one, deepfakes, it's a very interesting applications, but also very controversial, because here the goal is to port a person A facial features into a person B here. So an example of that would be, let's say on the left side of the image here, you would have the Elon Musk picture. And let's say I want to, why not, put Nicolas Cage faces on the original Elon Musk picture. So you can create fake videos with customized face. So it's very interesting, but it can be controversial. Quickly, there's also text summarization applications. Machine translation is getting better and better with AI. Interestingly, Google has moved from its more statistical approach to a more AI approach for humans for machine translation, because AI is now getting, I think, better performance in some case than humans for translation. So that's more examples of applications. I've talked about it pretty much. So as you can see, AI is can be applied in various numerous number of fields and industries. It will change the way we use transport, the way we do medicine, the way we do commerce. And just for fun, I've listed 4 other technologies, breakthroughs, inventions that have also changed the way that we live and the way different industry works. So the steam engine, electricity, computer, internet, they all have changed the way we live today. And these are disruptive technologies. And what we see here today with AI, it has the same potential. And I think it has already started. So with that in mind, with all these informations, we should ask ourselves as a company, as Matrox Video, for example, what if we use AI in our products to add a plus value, to improve existing products, for example. So that's why here I'm going to give you 2 examples of current and past AI projects that we've been working on, and it will give you an idea of how we use AI to improve existing products or future products. So the first product that we worked on, we wanted to start simple. So we chose an existing technology here in Matrox, an algorithm that we've designed. So we wanted to work on the video scaler engine, and the scaler purpose basically is to resize an input image while maintaining a certain visual quality. So right now with the current video scaling engine, it uses a fixed preset filters, fixed settings, fixed parameters, no matter what the input image is. So here, let's say you have an image with very high frequency details. You would scale it the same way as if we had an image with very uniform and almost blank content. So the goal here is to add AI, or a smart controller, which will adapt the filter settings, parameters to the content of the input image. So let's say you have desktop content, sports, news, or high frequency, low frequency details. You would like to have a smart controller which will control the scaler, so it would adapt the visual quality to optimize the visual quality of the resulting scaled image. So here it's the current non-AI pipeline. It's pretty much simple, straightforward. You have an input image. It goes through the Matrox scaler with fixed settings, and you have an input image of size B. So it's the same process for every type of images. Now, with what we did is we added a smart controller which analyzes an input content, and it decides which filters presets, how strong we want to sharpen the image based on what we're seeing in the input image. So with that smart controller added to the pipeline, we actually had a significant visual improvement, around 40% increase in the optimal choices. So that's one way to add a plus value to your existing products for without too much complicated stuff. Yes, this is the machine learning development flow that we followed during that project. It can be applied to all various kind of projects. This is a very basic and common flow. So there's three main phases here. The first one being to gather and prepare your data. The second one is to build and train your models. And once you're satisfied with your model performance, you're ready to deploy your model into real life applications. So what we did here for the data preparation phase is, of course, we gathered lots of images and videos that will be used as training the data. We did some data preparations, we did some cleanup, denoising, normalized the pixels values. And once that's ready, we built our models. We actually built 3 models, and the purpose is to compare them and take the best of the 3 model. So we built and trained our models with its hyperparameter tunings, model validations, testing, and then we deployed it into a examples project. It's not released yet in a real products, unfortunately. So it's pretty much the same slides as the previous one, but with the exception of we also did research and lots of readings, and the goal here is to get the state-of-the-art models and techniques currently in this type of applications. And that's very important because ideally you want to start with an existing model or start off with something that already exists and then adapt it to your own applications. You can design your own model, but it's safer and faster to develop a product when you start off with something that's already exists. All right, so that the scaling, the smart scaler project now is done. Now we're working on a different project that is focused on the video encoding process. So the video encoding process is, the goal is to compress visual information to obtain a lower transmission bit rate or a smaller file size. And in the video encoding pipeline, there's also a rate control module, which purpose is to choose where to allocate bits from a certain budget in a video stream. Its goal is to have the best video quality given a target bit rate. So let's say you have a video sequence, and in one of the frame, it has very complex scene or lots of small details. You want the rate control to allocate more bits in these kind of scenes, and conversely, in blank and uniform scene type, you want the rate control to allocate fewer bits, fewer data. So it's it has to spend wisely the bits and the budget that it has been allocated. So quickly about video compression, we are working with the H.264 and H.265. You may have heard about them. H.264 is also known as AVC for Advanced Video Coding, while H.265 can be known as HEVC for a high efficient video coding. So both of the video compression standards are lossy, so you lose visual information. It is used in many applications for live streaming, conference applications. Interestingly, it's also used in Blu-ray decoder, where the H.264 decoder would read the bits from your Blu-ray disc, and then decode it and send it to your televisions. And what is interesting with HEVC is that it is twice as efficient as H.264 for the same visual quality. So for transmitting very large video, such as 4K video, HEVC is a very interesting standard. But obviously, HEVC is going to be much harder to compute than H.264. Now, so the typical video encoding pipeline looks like this. So you would have an uncompressed video that goes through an encoder, and then the encoder would generate a coded stream, which is sent to the encoded buffer, which is emptied at a rate of the transmission channel. So you can think of the encoded buffer as a leaky bucket. And here the rate control would receive multiple information from the encoding pipeline, such as the effective bitrate, the fullness of the buffer, the video information, and the rate control would try to guide the encoder to obtain the best encoding quality through the quantization parameter, the QP parameter that we call it. Actually, the QP is simply a parameter to control the trade-off between quality and size. So what we're trying to what we're working on here is to add an AI module, attach it to the rate control module, so it would give extra insight to the rate control to make better decisions. Because with the previous pipeline, the rate control, the encoding process may have to repeat the encoding for the frame. It may require several passes to respect the bitrate constraints, the visual quality constraints. So it's going to increase the latency of the encoding pipeline, right? So we don't want that. We don't want the extra latency. So by adding AI to the rate control module, we want to make the rate control lives easier by giving extra information to make the decision faster and better decision also. So the goal here is to increase visual quality, optimal bitrate, reduce the latency of the encoding pipeline also. And fun fact, just from the latest rate control applications, Matrox got 3 rate control patents out of a total of 6. So we have a great expertise in rate control applications. All right. Now, there's a lot of challenges that we must be prepared to face. As you can see, there are several components that are working together. So we make sure that each of these modules are compatible within each other, that they are synchronized. We must also make sure that we support multiple video resolutions, video content, video format. Also, we expect the model to be huge, so we must take care that we must find a way to optimize the size of the model without impacting the model's performance. The goal here is to reduce the latency of the encoding pipeline, right? So we don't want the AI model to take a lot of time to compute its prediction, and add latency to the video encoding pipeline. Finally, yes, as I've said before, we want the rate control, the video encoding process to be running in real time. For instance, video streaming and conference applications are, this is a real constraint for these kind of applications. So here are more ideas where we can add AI to video compression. I'm gonna skip this slide here because I want to have the time to give you some tips and tricks for your first AI projects. All right, so the current tools and technologies that we are working with at Matrox for AI projects here is, first, we are developing with Python as a programming language. As with the AI framework, we are using TensorFlow, but we're open to use also PyTorch. It's still in evaluation. Then we train our networks with NVIDIA GPU. It's very nice because it's accelerating by a lot the training time. Finally, we are using OpenVINO and Vitis AI for deploying the AI model on different platforms, such as FPGAs. So in the future, these are my hopes for 2021 and beyond, is that we continue to explore where else we can apply AI in our products to add some extra values. I also would like to see our smart skater model to be deployed in a real life product and sell it to clients all over the world. Also, I'd like to see a further optimized and automated way to develop AI projects. And the last but not least, we wish to see the AI family in Matrox Video growing. We would like to add more people, more passionate people in our team. And oh, of course, no more COVID in 2021. So let's sum things up. I think I have 7 minutes left. You get to know a little bit more about Matrox Video. We did a quick introduction on AI. You had a chance to see 2 examples of AI projects that we are currently working on at Matrox Video. And now you must be saying, is this guy going to stop talking and give me the tips? Here we are. All right. So even if you don't have an AI background, you can still you can start using AI even if you don't have any knowledge, really. As long as you know how to code, you can start using AI in your projects. I'm talking about simple projects here, but because there's more and more tools available that make implementing deep learning models easier. I'm going to talk about it in the next slide. And what's nice right now in the AI field in 2020 is that even if you're a biologist, chemist, people working in finance, a software developer without AI background, you can still use AI because there's a lot of tools that make it easy to deploy AI in your projects. Also, even if you don't have the latest computer, the latest and greatest computer and GPUs, you don't have to worry because there's lots of cloud platform right now that allows you to do your computing remotely. And these are very high performance computing machines. So let's talk about that. So as for the AI framework, if you want to get started, choose your AI framework, right? We have the 3 most popular here that I listed: TensorFlow, PyTorch, which are more focused on deep learning. You also have scikit-learn, which have nice, great tools, but they are less focused on deep learning. They have more traditional machine learning algorithms, such as SVM, KNN, K-means, etc. Um, a nice platform that I like a lot is Kaggle. It's a platform where you can compete with other passionate people, AI passionate people. Uh, you have prize money if you have a nice like top 3 solutions for a certain competition. But it's not only a competition platform; it's also a learning platform. There's lots of basics and intermediate level exercise where you have to code, where you get to learn and code at the same time, and all that is done on cloud through your web interface. So you don't have to install anything. Just open an account and you can start coding. Um, Also, yeah, I've talked about the computing resources and GPUs. You don't need that if you want to get started. Now we have lots of cloud computing platforms such as Google Cloud Platform, Amazon Web Service, uh, Microsoft Azure. And what's nice about them is I think they're still offer it when you first register with them. They give you free credits to compute on their platform, and they have very nice tools for AI also. So you just need to open an account. You don't need to install anything on your computer, and you can get started. If you don't want to get involved with these kind of platforms, you also have Google Colab that I like a lot. If you want to try test a code quickly, you can use Google Colab. All you need is a Google account. The coding and the training is on the cloud. You can use their GPUs to train your models. So it's very nice if you wanted to start AI projects. And finally, if you want to get serious about knowing more AI, how it's working under the hood, there's lots of online classes. But the one that I like is Coursera. They have nice AI courses, both free and paid classes, and you get to also code. It's not only theoretical classes. You also have projects where you have to code, and it's very nice to learn quickly about AI. So if you want to start with an AI project, I suggest you that you start with an easy and well-documented project, such as cats and dogs detection, handwritten digits recognition with the MNIST database, flower classifications, house price predictions, and so on. The goal here is to, if you encounter any problems, it's easier to get solutions on the internet, on forums, on Stack Overflow, or it's easy problem. So you get to know how these AI framework works and how to implement your AI models quickly. So yes, questions to ask before starting an AI project. Do you really need AI for your task? Sometimes there's existing solutions that are much more simpler, yeah, and you don't necessarily need AI for your task. It may be overkill. So is AI justified in your project? Second, do you have or can you create a data set? Because as I've said before, machine learning is based on training data. You need data to improve your model to make better prediction, right? So you need a data set, or can you create your own data set? And finally, do you have the time? I know especially with CodeJam, time is limited. So you have to ask yourself, do you have the time to experiment, play, train, optimize AI models? So if you've answered yes to all these questions, here are a few tips. I know it's not a lot. I wish I could give you more, but time is limited. The presentation is almost over. So if you can, use pre-existing models, and if you can pre-train models, it will save you a lot of time. There's TensorFlow Hub and Torch Vision models. which contains lots of pre-trained models and very performant models. If you can use cloud platforms to train models, do it. They have very strong computers there. Instead of training on your laptop, on your CPU, go for the cloud platforms. As for the data sets, make sure you split your data set for training. Right? This is the basic tips. Split your data sets in three: one for training, one for development, model optimization, and one for final evaluation. And make sure that these three databases come from the same data distribution. And finally, make sure that your model is not overfitting or underfitting. If it's overfitting, it means that your model is overlearning the database and your during training. So use regularization techniques and make sure you don't underfit also. So don't underlearn your model. So that's it, guys. I hope you guys had fun, and good luck in your CodeJam projects.
Thank you everyone for coming. If anyone has any questions, please feel free to ask us. Yeah, and thank you for the workshop.
Yeah, no problem.
Hope everyone enjoyed it.